Okay, for those that don't know me, I suspect you all do, my name is Benjamin Drew. I'm the Program Leader for Automotive Engineering, and I'm also the Module Leader for this new module called Vehicle Dynamics, okay? Which is one of the new modules as part of the Integrated Learning Framework. So I thought I'd just do an introduction to this module, and then later on this afternoon, I think you're all due to be in a tutorial for this module in 2Q5051, I think, at 3 o'clock, I believe. And obviously in that session we'll run through like an example problem. But this is the introduction to the module. I'll talk about welcoming you. I'll talk about the course structure and assessment for the module. Some contact details for myself. Talk about the course notes, the schedule of what we're going to be doing, some stuff about notation, and then some things about vehicle conventions. Hands up if you're automotive. Okay, so the rest of you guys are mechanical, and you're all into cars, car nerds, geeks. Yep, I'm included in that group. Okay, so that's what we're going to be talking about, obviously. So in terms of the structure, obviously, it's a 15-credit module, which runs in one semester one only, okay? So it's from now until the end of January. And for each week, we've got a 2-hour session with the whole cohort, so all of you on a Friday, from 1 till 3, I think, on a Friday. And then the following Monday, there's a series of 1-hour tutorials, okay, or practicals. And they're going to be running actually from next week, so although we're not going to have a lecture, we're going to have the tutorials, and so like I said, we'll do some fun stuff during that session on Monday, and then we'll start the proper content the following Friday, and then practice that content in the tutorials the following Monday. Okay, so 2-hour lecture or lectorial, and then a 1-hour tutorial or practical on the Mondays. Okay. In terms of the assessment, there's 2 elements of the assessment. Component A and Component B. Component A is the end of semester open book online exam, okay? And then the other part of the assessment, part B, is a series of online e-assessments that are spread throughout the teaching block, okay? And they're going to be a mix of, some of them will be based in DOIS, okay, if you've probably used DOIS in the past, and then some of them are also going to be using MATLAB grader, okay? It depends on what I'm testing. Okay, and the details of those things will be released in due course, okay? But like I said, there's going to be a few. I don't know quite yet how many, probably 3 or 4 online e-assessments. They're going to focus on the various sections as we move through. Okay. So obviously, I'm the tutor for this module. I'm going to be doing all the sessions, okay? My name is, obviously, my email is benjamin.drew@ue.ac.uk, and I live, currently I'm in 4Z36, but I'm soon going to be moving into 4Z33, okay? That's where you'll find me. Like I said, if you want to come and get in touch with me and I'm not in my office, then drop me an email, or you can find me on Teams and those sorts of things. So, like I said, my door is open to you. Okay, so I'll talk a little bit about the course notes, okay? We've got a number of topics covered in this module, separated into a bunch of chapters, okay? Generally it's going to be sort of 1 chapter a week, although we might spend a couple of weeks on a couple of other chapters. So obviously we're starting with this chapter, chapter 1 of the course notes. Is this introduction, so it contains all the information about the module and those sorts of things, and the schedule. Chapter 2, I was going to spend 2 weeks on that, looking at single degree of freedom vibrations, okay, because this is obviously vehicle dynamics. The basics of a lot of dynamics is around things that oscillate and springs and dampers and those sorts of things. So we're going to focus on some of the sort of basic fundamentals before we move into vehicle-specific stuff. Again, multiple degrees of freedom vibration. Some of the stuff will actually be sort of review from last year when you did dynamics with Gary. Okay, but obviously we're going to be looking at it slightly more depth and that sort of stuff. And obviously with the application of how it's used in automotive applications, automotive engineering. Then chapter 4, look at forces on the vehicle, including some modelling, looking at multiple degrees of freedom like a quarter car type thing. Tyres is chapter 5, steady state handling, Again, that's going to be a 2-week topic, looking at steady-state handling, how, when a vehicle goes around a corner, what's the characteristic of the cornering. We look at things like understeer, oversteer, neutral steer, and those sorts of things. Okay, and we build up from basic, linear tyres, low speed, all the way up to sort of high speed with non-linear tyres and those sorts of things. Looking at slip angles and various other things that, like I said, we'll get into the details. Okay. Chapter 7 is around suspension, looking at springs and dampers. Okay. Chapter 8, again, more suspension, looking at different types of suspension and the parameters that are important when setting up the vehicle. And then chapter 9 is we focus on one particular type of suspension called double wishbone suspension, and we look at the kinematics, which is the way the suspension moves and the way that behaves. Okay. Notice that some of those chapters have the word lab after them. That's because part of the topics that we're going to cover are going to involve some lab activities. Okay, these might be demos. They're going to be. I'll try and get you involved as much as possible. They're going to be on the Monday during those practical sessions. Okay, so the force on the vehicle, we've got we're going to be looking at the Corsicar rig in the Dynamics lab. Okay, tyres. We've got some stuff on the rolling road that we're going to do with tyres. And then chapter 7, springs and dampers. There is a damping testing tool in the Dynamics lab that we're going to use. Okay, and then the double wishbone suspension kinematics. Again, there's a rig downstairs in the automotive lab that we're going to be using for that task as well. Okay. For each chapter in the course notes, there is a sort of series of exercises or questions. Okay, for you to go through in your own time. During the sessions, we're going to go through some exercises during the lectorials, okay, and also some examples. And then, obviously, during the tutorials where we're not doing a lab, then obviously that will also be a problem class where I shall present to you with a problem, and you can work in groups on solving those problems, okay. Like a structured tutorial, as opposed to you freely working on the end of chapter exercises. Okay, it's going to be a bit more facilitated than that. Okay. But clearly, obviously, 15 credit module over one semester, normally 150 hours of your own time. 36 of that will be contact time, okay, and obviously outside of that time should be a focus on independent study. And so obviously during that time, it's wise to spend a bit of time going through some of those exercises at the end of the chapters. There are lots of exercises, and obviously all the solutions are available as well. Before I move on, in terms of Blackboard, you may notice that it's not actually listed on your Blackboard thing yet. It's not listed on mine either, okay, which is why it's not up there. I've asked for it to be activated, then I can obviously put loads of stuff on there and content and make it available to you guys. But that's why there's nothing currently there. But I'll show you what's supposed to be on there. Obviously, these slides are supposed to be up there, and the first part of the notes obviously is supposed to be up there. In terms of the schedule, I'll talk about the course notes first in a second. The course notes and the slides are going to be linked together, okay, like they've been in previous modules you've had with me. Basically, I'll show you. In fact, the course notes. I've got the course notes. You'll see that there's a. If you look at the course notes, this is chapter 1 of the course notes. You'll notice the numbers in the margins. Okay, well they relate to the slides that I'm presenting. Okay, so if you go down here, slide 6, you'll see that there's a bit about along the margins of these course notes. Well, if I go back to the presentation, you notice that we're actually on slide 6 at the moment, and it's got the same text. So, like I said, if you're watching a lecture or watching the recording or going through the slides, and you can read along with the notes, and they're all linked together. Okay. So in terms of the schedule. Okay, we're on week 11 at the moment, UE week 11, we're going to be using UE weeks, okay? That's the 29th, that's today. Obviously introduction to the module, okay? Now, next week, on the 7th, which is the Friday, okay, we're going to start with Chapter 2, Single Degree of Freedom Systems. Again, broken into 2 weeks, Part 1 and Part 2, okay? Then Chapter 3, Multiple Degree of Freedom Systems, I've got a spelling mistake there, okay? Forces on the vehicle, tyres, steady-state handling, then there's Project Week, when there's no teaching for you guys, okay, to focus on projects. After Project Week, Chapter 6, again, Part 2, springs and dampers, types and parameters, and the double wishbone suspension. Those dates are on the Fridays, okay, throughout the semester. And then after Christmas, after the winter break, we've then got one more session on the Friday, which is going to be revision, because obviously the week after that there'll be an assessment for you guys to do. Okay, so that revision will cover previous topics. So those are the Fridays. Obviously, the following Mondays after those Fridays will be the tutorial sessions related to those things. It doesn't make sense to do the tutorial or the lab before you've done the theory. So, like I said, it's going to be like a week later. Obviously, in the notes, SI units is what we're going to be using. Okay, if you're given units in a non-SI, then obviously you'll probably be required to convert it, and that's straightforward to do. If you've got letters that are non-italic, they're going to, in all likelihood, be units, and if they're italic, they're likely to be the variables. And obviously, we will also use dot notation in lots of areas where the dot indicates a first derivative with respect to time, so d by dt. So if you've got displacement, which we're calling x, okay, then x dot is going to be velocity, and x double dot will be acceleration, okay. But that rate of change with respect to time applies to all sorts of things. So we could be looking at things like, your rate, which would be your angle, and then with a dot over that, your angle, which could be called r or something. Then that will be r dot will be your rate, and those sorts of things. So, like I said, it's basically a shorthand way of writing d by dt, so something that's changing with respect to time. Okay. So like I said, x double dot, x dot, those sorts of things, that's what we're going to be using. And lastly, in terms of the vehicle, we're going to be using conventions set out by the Society of Automotive Engineers. Okay. So this is a chassis of a vehicle, or a body of a vehicle, with the origin at the centre of gravity. Okay. And then you've got the x-axis, which is the forward-backwards axis. Okay, so that's longitudinal motion. You've got the y-axis, which is lateral motion, side to side, and then vertical motion is z. Now z is downwards because this is the right-handed coordinate system. X is your first finger, y is your middle finger, and then thumb is your thing. And if you point them in the right direction, z is positive downwards. Okay, centered around the centre of gravity. And then along those three axes, okay, you can also rotate the vehicle, and that gives you the 6 degrees of freedom. So around the x-axis you've got roll, vehicle roll, okay. Around the y-axis you've got pitch, forwards and backwards, squat and dive, okay. And around the z-axis you've got yaw, which is the rotation of the vehicle around the central vertical axis, okay. So there's your 6 degrees of freedom of a vehicle chassis, okay. Roll, pitch, yaw, and then you've got longitudinal, lateral, and vertical motions, okay. And so the chassis can move in all those directions. So like I said, this SAE say that it's at the centre of gravity. The thing is about that, though, is the centre of gravity can move around. Okay, so some car manufacturers actually use a different origin point. In my past, I was doing some research, and we were involved with BMW as a manufacturer, and their designs always put the origin of their coordinate system in the centre point of the front axle, okay, which doesn't move. Okay, so everything forward of the front axle had a positive x value, everything behind it had a negative x value. Okay, and then obviously they had the right side to side, the lateral was y, and then obviously z was also, I think z was downwards as well. Okay, so like I said, but it depends on who you work at. SAE, say the centre of gravity. That's it. Yeah, as it happens. And then, so I mentioned the translational motions. Well, we actually divide some of the motions into those things as well. So you've got longitudinal dynamics, which is, like I said, pitch, acceleration, and braking. So things that happen in a straight line. Vertical dynamics, you've got bounce, which is the whole body moving up and down, pitch and roll. Okay, and then lateral dynamics, which is going to be your roll and pitch if you're accelerating things at the same time. And so if you think about the longitudinal dynamics, that's stuff that has an impact from driving in a straight line. Okay, so things like accelerating, braking, pitch, dive and squat. Okay, those are all to do with driving in a straight line. Vertical dynamics is to do with the road input under the vehicle. Okay, so that's where the bounce, pitch and roll comes in. And then the lateral dynamics is around what happens in the corner. Okay, So that's where the roll and the yaw comes in. And obviously, if you're accelerating or braking into a corner, then you've also got some pitch going on as well. Okay. So they're the domains of movement. And then the last bit of convention, this looks a bit complicated, okay, but we're going to be using it when we start talking about cornering and roll. But basically, it's there as a reference. But we can identify some of the things. The front of the vehicle is this slide here, okay. On my F1 and F2 are at the front, okay. The back of the vehicle is back here, okay. Now we've got big F, which is the cornering force being generated by the interaction between the tyres and the road. And obviously that could be separated into the front and the back. And obviously these are the forces, the reaction forces keeping the vehicle down the corner. Okay. The wheelbase, the distance between the front axle and the centre of gravity is denoted by C. Okay, here. The distance between the centre of gravity and the rear axle is D. C plus D equals L, which is your wheelbase. Distance between the front axle and the back axle. The height of the centre of gravity from the ground when the vehicle is not rolling is denoted by H. Okay, here. And that's the distance between the ground and the centre of gravity height. And then we've got these things called roll centres. Now, when a vehicle rolls, it rolls around this roll axis, not about the centre of gravity. Okay, the centre of gravity will move, and the vehicle will roll around this roll axis. The roll axis is denoted by a line drawing the roll centre at the front axle and the roll centre at the back axle. We'll talk about roll centres in much more detail later on. Okay, and then obviously between that roll axis and the centre of gravity, there's a dimension A, and then the HF and HR are the heights of the roll centres in front of the rear. And the line joining the two will become the roll axis. Okay, this is just like I said, the basic diagram, just showing some of the things. So when we're talking about roll and those sorts of things, and cornering and roll centres, you know what we're talking about. Okay, and like I said, that will be useful later on when we talk about cornering and those sorts of things, just to give you a bit of an idea. T is obviously your track width, that's the width between the tyres. This is making the assumption that the front and rear tracks are the same. Obviously you might have TF and TR if you've got different track widths and stuff. Okay, so it's like I said, it's just a bit of a diagram to show what's going on. So that's the end of my presentation. What I thought I'd just show you is some of the notes. I've got chapter 1 of the notes here. Okay, so the notes is going to be basically like an ebook. Instead of it being one ebook that you download from the beginning that's got everything, it's going to be released on like a week-by-week schedule to, so it's not too much in one go. Obviously, this is the introduction note, so it's basically it kind of covers what I've covered in the presentation with a bit more detail. So you can obviously read it. Like I said, the assessment is 80% of the module mark. E-assessment at the end. Exam online. And then we've got these series of e-assessments using DUIS. Obviously, there's some details about the course. So this contains a bit more information about what's in each of the chapters. Okay, so like I said, single degree of freedom vibrations, free and forced, damped and undamped, and then multiple degrees, looking at 2 and 3 degrees of freedom. Okay. Natural frequencies, mode shapes, and those sorts of things. And obviously, that leads directly into things that looking at what's known as the quarter car model. If you look at a car in plan view and you chop it into quarters, okay, you take one of those quarters, there's a 2 degree of freedom system. Okay, so basically you've got the road, and then between the road and the wheel you've got the tyre, which is a spring essentially. There's a bit of damping, but nothing compared to the shock absorber, so we often neglect that damper. So between the road and the wheel you've got the tyre, which is a spring, air spring, and then obviously between the tyre and the body you have a spring and a shock absorber. Okay, and obviously that middle mass, the tyre, includes the tyre, the hub, the wheel, and the brakes and various other things that are part of that unsprung mass. That's what the unsprung mass is. Okay, and then between that mass, you've got the vehicle body, or quarter of the vehicle body on top of it. And there's a typical 2 degree of freedom system. So clearly there are 2 natural frequencies and 2 mode shapes. Okay, like all 2 degree of freedom systems. And those mode shapes, in particular in vehicles, have a particular name. Okay, so you've got body bounce, which is the body oscillating, and then you've got what's known as wheel hop, where the wheel is oscillating. Okay, and those, like I said, we'll look at that theoretically, but we'll also look at that in the lab with the cortical rig down with is the intention. And we can model it using MATLAB, and I'll do that as well. Okay. So yeah, chapter 5 looks at tyres. Okay, so like an introduction to tyres. Tyres are quite complicated as a vehicle dynamics thing. Okay, it's a bit, rubber is one of those things that's quite well, it's like I said, it's quite difficult to it looks quite simple, but they're actually quite complicated. But we'll talk about that, and we'll talk about how tyres generate grip and different theory around modelling. How does they work? Often tyre modelling is actually based upon empirical evidence, and so they test the tyre, and then you can build a model based around the test results, as opposed to actually sort of developing it from first principles. Like I said, because of the way tyres interact with the road surfaces, there's all sorts of variables at play that make a difference. Okay, and like I said, we'll look at tyres. The lab associated with this is actually on the rolling road, and we're going to be looking at tyre construction and tyre design. And we've got the car that's on the rolling road, and we're going to be fitting it with different types of tyres, and looking at the impact that tyres have on vehicle efficiency and losses and that sort of stuff. So we've got two different tyres that have got a big difference in terms of rating, and we're going to see how does that evidence itself using the rolling road. So we'll be using the rolling road for that. Chapter 6, like I said, is going to be 2 weeks, looking at steady-state cornering, high and low speed. The way that the vehicle generates cornering grip in high and low speed is quite different. Okay, and obviously, like I said, we'll start off with very straightforward linear tyres, and then start looking at non-linear tyres and how they differ. Okay, and then working through the fundamental equations of cornering, we can actually sort of identify what cornering characteristic the vehicle has, whether it's a vehicle that's likely to tend to understeer, okay, or tend to oversteer, or one of a neutral steer. And the way what those definitions actually mean, because you probably hear them if you're reading magazines and that sort of stuff, and if you're watching drifting and all sorts of stuff. Well, these are all part of that thing: understeer, oversteer, and neutral steering. Okay, and like I said, we'll talk about how they're actually defined specifically, what they actually mean, and the critical and characteristic speeds as well. And then chapter 7, like I said, components using suspension systems. So we're very much focus on different types of springs and dampers. And the lab associated with that is going to be using the damper rig in the dynamics lab. So we'll be looking at damping constants and how you generate damping forces. And then, like I said, chapter 8 is going to be looking at suspension types. So things like double wishbones and McPherson struts and super struts and trailing arms and diagonal trailing arms, all these sorts of different types of suspension systems that can be used in a vehicle, looking at some of the examples and stuff and what's currently on the market in a sense. And then lastly, chapter 9 takes a deeper look at double wishbones, specifically because obviously in many motorsport applications double wishbones is what's being used, okay? And there's lots of interesting kinematics around double wishbones, lots of benefits that you get through double wishbones, but many cars, only the bigger cars have them because of the space constraints and some of the cost implications and that sort of stuff. But like I said, we'll take a look. It's quite interesting what you can do with double wishbones of certain types of parameters. Okay, so there's more stuff about the notes. There's the schedule, which I've just think I'll have to check that spelling mistake. Notation, vehicle convention. So it's all the stuff that you've got. So that's it for the introduction. Are there any questions?